Hi, my name is Tim, and the submission I made to the 21st Century Music Practice Research Network's online symposium on the theme of restriction and affordances comprised a 15-minute film in which I documented the composition of a piece of music which was created through coding and was seeded by a quote by Stravinsky, which was part of the notification email that was sent round to people as part of the call. That film was a sped up version of the production process, and this film is the expanded version with all the detail and takes something like 1 hour and 10 minutes to play. So if you're interested in finding out more detail about how I composed that piece, then this film documents that. I should say that I'm not using Sonic Pi here in a traditional way to live code. I'm using it to create a fixed composition, and I'm also trying to use metaphors and language that would be familiar to composers who come from a more traditional music background. So I'm trying to work within those limitations, and obviously the limitation of just using the Stravinsky quote to seed all the musical material, all the note information that's going to be used within the piece. So this is the basic environment. The key thing is that my code's going to go here, and over on the right hand side is where is a post window, so I can post some messages from my code into that post window. That's going to be kind of useful, as you'll see in a second. So I'm just going to copy these bits in here, and I'm just going to comment them out. So you'll notice the hashes at the beginning means that Sonic Pi is going to ignore that, but that can be like my title. So actually what I want to use is just this this little piece of text here, because I think it's pertinent. And actually, I think when I think back to my understanding of how Stravinsky composes, and I look at that old footage of him creating musical material in terms of in almost like chunks and patterns and shifting stuff around, he cuts out bits and moves it around on the score and puts it together. I can see that there are kind of certain similarities in the way that I'm going to approach doing this as well. Okay, so the first thing that I need to do is, what I want to do is I want to use this text, and I want to use the underlying numeric values, the ASCII values for this text, to seed my musical patterns. So the first thing I want to do is I want to deconstruct that sentence into words inside Sonic Pi, and then I want to convert those words to letters, and then I want to extract the number value for those letters and create little patterns of numbers that will be derived from that text. So okay, so I'll say I'm going to put that as my title, and then I'm going to create some containers for the words here and for the numbers. Typing live is actually more nerve-wracking than I was expecting. Okay, luckily there's something in Sonic Pi which allows me to split this where the spaces are. Okay, so I'm going to split this text here. It's going to go into title, and then I'm going to deconstruct that. I'm just going to... Okay, so that's run. So now, if I print that, you'll see me doing this a lot, so I'm just going to explain what happens. So I'm going to print title there, and you'll notice in the post window that I've now got all those words split into individual, or that text split into individual words there. I can also do something like, I can ask it what's the length of that of the list that I've got there, and it will tell me 11. So I've got 11 words along there. Okay, great. So I can then use that. So what I'm going to do now is I'm just going to create 2 loops, and I'm going to pass through that list, and I'm going to take out the words. I'm going to convert the words to numbers, and then I'm going to put those numbers into another list. What we've got here is you can see that tick is my counter going around the loop here. You can only use the tick once, and then I'm looking into that. I'm looking at that counter by using the word look. So I've got one loop that's going around the list that way, and then I've got another loop inside which is looping around each of these words and taking out the converted number of the letter and putting it into num. And then I'm printing out word and num, and you can see that I've got the words and then the number equivalent underneath, and there it is going through those 2 loops. So that's that part done. I can take those 2 out now. I know that that's finished. Right, the next thing I want to do is think about how I'm going to use these numbers. So I said that I want to use some of the metaphors from conventional music. So maybe the thing I need to think about is score, maybe a score and then parts in the score, the instrument and the player. Okay, so I'm just going to create these sections here. I'm just going to comment these out again so they get ignored. Okay, so the score is just going to be some lists, basically, and so are the parts. They're just lists of data, which exactly as you would see on a stave, just lists of notes essentially. So I'm going to say the score. I'm just going to create a very small score to start off with. I'm just going to duplicate that there. I'll just call that PCH for patch essentially there. So I've got my score. Now my instrument will need to be defined. So and my player will be a live thing that's interacting with the instrument. So that's going to be in a live loop. This is my first one, so I'll call it player 0. Okay, so essentially what I've just really quickly defined here is that's a static instrument, that's a live player. The player will be playing the instrument, but it will be passing some parameters here, which will be its part. And these parameters will be set by what the score is determined in the score. So essentially they will have lists which will relate to these parts, and then these players will pick out a list and pass it to the instrument, and the instrument will play those parameters. So let's see if we can just get something to work. Right, the first thing we need to think about then is what type of thing do we want our instrument to be able to handle? What type of thing do we want the player to play? Well, I've thought about this, and these are the type of things that I've come up with. So basically, we can think of our instrument as having an on. We might want to turn it on and off. We want to pass it a pattern to play. We want to tell it how many times to repeat that pattern. We probably want to be able to control the length of the pattern. We want to, in Sonic Pi, there has to be a sleep time. That is essentially the duration for each of the when you ask it to play something, it's a duration that you're asking it to play for. So we need to have that in there for Sonic Pi to be happy. Maybe we want to control if there's going to be any gaps or rest periods at the end of the pattern. We'll call that gap. We want a sound. It needs to be passed with a synth sound of some sort, which we can control. So that's the signal. We need, okay, maybe we can play some effects, put it through some effects. Maybe we'll have 3 levels of effects. Maybe my computer can handle that. Then it's the likelihood is that although we're using these patterns as they are, we can move them up and down and transpose them, because we're going to, otherwise they're all going to be clustering around the same region. So we'll transpose them. We may want these patterns to be all the notes in the pattern to be played simultaneously, like a chord, or individually as a sequence. So I'll put chord in there. Each of the notes will have an envelope or a shape, so I'll put the envelope in there. The amplitude or the volume for each of the notes. Also having some sort of control over things like a cutoff or some parameter. I'm just going to put 1 in, so this can be used for different things, but I'll call it cutoff low, cutoff high. So this is the lower end of the register, or whatever the parameters are at the low point and the high point, and then the increment cutoff between them. I'll put in there, and also maybe the pan in there. So I could go on and I could do more, but anyway, that's more than enough for me to try and do in the time I've got available. So these, because they're inside these braces here, these are bits of data that can now be passed into the instrument. So basically, the player is going to need to be able to pass these through, and our patch here needs to, or the part needs to have all these values there. So we've got 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We've got 18. So basically, this is going to need to be 18 in length, and we've got 2 there. It's probably going to be handy to take those, just to remind us what those 18 things are, to take those there and comment them out, but put them there so we can see what these 18 values represent here. Then we're going to need to, okay, so inside this instrument we're going to need to use these to do something. Well, these are going to be used inside the instrument to actually make the sound. And then the player at some stage will call the instrument like this. So, and it will pass it whichever patch it is that it's needing to play. And so all these values will be passed into here. So this is PCH 0, 1, 2, 3, 4, 5, 6. And I can say, so if this is let's say, well, we're going to need to first get the instrumentalist to play from their score, their part here. So if I'm saying that this is part 0, so player 0 playing this part. We've only got 2 parts at the moment, but this will extend as our score extends. I can get to look into that part. And I can ask it to go along to the end of the line to its length and do this a number of times. Okay, so what I'm asking the player to do essentially is read along the stave. I'm asking him to read along. So for the score part.length, keep reading essentially, and keep sending, keep playing your instrument. And what I need to do is keep track of which element we're on, 1, 0, 1, 2, 3, 4, 5. And that we can put into a variable called P. And I'm going to create its own little counter there to move along here, because we've got one counter that's moving down the parts and one counter that's moving across, so we need to have two counters. Okay, so P is going to be telling me which patch essentially, so it's going to tell me what's in there. So my patch is 0 to start off with, and then next time, okay, so it'll play that one first time, and then in next element of the score it'll play that one, and then I might jump to 5, and it might play 5, and then it might play 10 or whatever, depending on how the composition unfolds. So so I've got P, right? So I need to pass it. For this one, I need to pass that element into there. So that's going to be PCH, and I need to tell it which row to go to. So that's going to be determined by my p-value, because I would pick that up from there. And then I need to tell it which element. Well, that's just going to be 0, and then we're just going to go across. Okay, so this is my player playing its instrument and going along its score, and it's only got 2 parts to play so far, 0 and 1, and then those will increase. So let's see if we can actually get some sound out of the instrument. So let's think just to simply get things working. Okay, what's going to determine the pattern? Well, the pattern is going to come from the words here. That's going to be giving us our pattern. So at the moment we've put that list of numbers into something called num, remember, and we printed those out, so we know that we've got 84 as is T. So let's load up pattern here. We'll leave the on off and we'll just load up pattern. So whatever the number that gets passed in here by that's in the patch, that value there will determine which word we're looking at in the list. And then we're going to take the numbers back and we're going to put it back into the variable called pat. Okay, so we've got that. Then let's think about, okay, well, reps is just going to be how many times we're doing it. So we can just say whatever's in rep is going to be repeating around a certain amount of times. And the same with length, because that's going to be how many elements are in the pattern. So rep is how many times do we repeat the pattern. Length is going to be the length of the pattern, so how many elements are in the pattern. So we can do that, and then in here is where we're going to actually play something. So let's just say play, which is Sonic Pi, is to play a note. And the note we're going to play is inside the pattern, so we can say pat. Now what we're going to do is we're going to ask Sonic Pi to just loop around this pattern. So we take the first value, the second value, the third value, and it's a special thing called ring, which allows you to ring around a pattern. And then we're going to use the counter again, tick, to do that. So it's just going to go from one value to the next. And what I'm also going to do is I'm going to add in the transposition there, so we can move these two patterns 0 and 1 we can move them into different registers so we can hear clearly that we're playing two different patterns. So that's going to be that value there, whatever's passed in there, which is going to be somewhere around here in our stream of data. Okay, and then of course we have to, because it's Sonic Pi, we have to tell it to sleep before it does the next action. And what do we tell it? Where do we get the data from? Well, we've got it here. It's passed in by the instrumentalist, so SLP is there. Okay, so I can't believe that this is going to work straight away, but let's see what happens when I run that. Okay, so it's what I haven't done is put any data in yet, so that's probably why it's thinking I can't sleep for 0. I need to sleep for an amount. So let's see if we can put some data in. So the first thing is the on-off. Well, we're not using that at the moment, but anyway, 1 we could use for on eventually. The pattern length, let's say 4. Go around the pattern. No, sorry, the pattern, not length. The pattern itself. Let's go for pattern 0, which will be the. And then the pattern length will say we're going to go around that 4 times, and then we're going to go around the length. The pattern 4, in fact I'll make that twice. Then the sleep time I'll make 0.125 of a beat, so the default is 60 BPM, so we're talking about 8th notes there, semiquavers. The gap, nothing. The sound, we just go for the default 0. FX 1, 2, 3, no, and here's the one that I want to put in, the transposition, so we'll move that down minus 12 semitones, so it'll bring it into a better register, because I can see those numbers are going to produce something quite high. And then we'll, in fact what I'll do is I'm just going to copy that, and so now SLP should have something in it. Okay, so we've got some sound there, and it didn't know what to do at the end, so it came to the end of the score and it was still trying to play, so we need to put a stop in there to see if we can stop that error. I think let's just see if it'll, okay, just to prove if it's playing or not, let's just reverse. In fact, let's go 6 and make it 4 and 2, so we'll reverse those round. Okay, so when we play this now, we hear the default sound being played there. Doesn't look like it's playing both those patterns one after the other. Let me just think about why that is. Oh, okay, so I'm just going to stop this, but I've realised I've stopped the instrument, which makes no sense at all. You have to stop the player. When he finishes a score, he stops playing, essentially, so that might help. The other thing is I've got all these synth notifications coming in, which is cluttering up that post window. So if I say use debug false, then it would suppress those. In fact, I might put that at the top there, and I can turn that on and off. The other thing I might want to do is to actually have a look at what word is being, so I can put print word and then whatever the pattern number is. The word should give us, so let's have a see if that, okay, so we've got the more coming up here. We've got, so that means that it's playing that first, and then that 0 is pulling out this one, giving it to the instrument. That is pulling out this one, giving it to the instrument. So far so good. So let's think about some of these parameters here and see if we can embed some of those into this instrument now. So the sleep time we've already done, that's there, so that can go. Let's think about the sound. So the default sound, the bleepy sound that you just heard, obviously we can use different signals. We don't have to use that sound. So there's actually, in fact, before we do that, let's just do the on-off switch here. So the really easy toggle for this is just to say if the on off is 1, play it, and if it's not, don't. So if I play that, stop it, and then I just change those to 0, stops it. Simple. Okay, or I can just not play the first one and just play the second one. Yep. So that's that one out of the way. What else have we got? Oh yeah, the sound. So the let me just turn these off a second. There are lots of effects and different sound sources that you can use in Sonic Pi. And if I just come up to the top here, and first thing I do is say you can see that there I've got 2 long lists of synth types and effects and stuff that are all built into Sonic Pi, and they're all documented so you can go to them. But the nice thing is that they're in lists, so we can just access those lists if we want to, which is what we should do in the instrument to pull out what instruments and effects we want to use. So we can say after we've chosen the pattern, maybe we can say okay, so now we've got our sound plugged in, we've got our FX 1, 2, and 3 plugged in. Everything's set to 0 at the moment. But let's see if we can play this now. And for this part of the score, let's see if we can go to so we've got the sleep, the gap, and the sound in there. Let's say I'm pretty sure if I do 25, it's going to be piano. Great. Okay, so we know that that's working. So whatever number I put in there is going to choose my different synthesizer, and I've got my effects as well. So I could put in 25, and I'm pretty sure that 28 is reverb, just a standard reverb at the moment. So yeah, so there's a bit of reverb on that, which is fine, or something. It's a bit crusher, so we can, yeah. So there's lots of things, and all these have their own parameters as well. So there's kind of parameter sets inside parameter sets that you can work with. So I'm keeping it reasonably simple at the moment. Right, so we've now dealt with this guy here. We've now dealt with all this guy here. We're gradually kind of plumbing all these things in. Okay, so everything that we've been doing is sort of local to the instrument now. Before we go on, I just want to add in a couple of things that it might be useful to sort of have global control over for the whole piece, as opposed to just for each particular instrument. So one thing that might be obvious to have in is just the BPM for the piece. So the Sonic Pi's default is 60, but if we wanted to change that, we could do that. But we'll just plug that in as 60 for now. The other thing I think is that although we can transpose individual parts, individual instruments, we can move them up and down. I think it would be, I'm going to have something called GT for global transposition, in case there's an instance where we want to put the whole piece up or down. And in a second, there's going to be a reason why I want to have 2 of these, which I'll explain in a second, because I'm going to be handling the playing here of the MIDI notes slightly in 2 different ways. So I might want to do that globally. And the other thing is that we're passing something in which is called the envelope, and of course the envelope is typically made up of more than one point, and it would be, I think, too labor intensive for this little project here to have all the points for all the different patches. So maybe a good idea would be to have something we could call env master, and then we could have a list of values which may be, I don't know, I'll just do okay, so we've got now 1, 2, 3, 4 envelopes that we could then plug in here, 1, 2, or 3, or 4, and then that would tell the instrument which one of these to use. So the question is, how do we then get the player to do that? Well, once we've told it what note to play, we can also then, you can see there's lots of parameters here, so we can say attack, and maybe I'll just call that a now what I want to do is I want to be able to the env parameter here, which is inside our patch. So where's that? It's transposition, there's the chord, and there's the envelope. So if I say 1, then hopefully it's going to pick out that particular envelope, and then I can say, okay, whichever. So I know that I'm on patch number 1, so I need to tell it that go to the envelope master, whichever envelope is being passed to the instrument in env, and then I want for the attack it's going to be the first element, and then there's a little more I'd like to add to this, which is I'd like the envelope to flex depending on the amount of gap and the amount of sleep time that the notes had. So if it's a short, I'd like it to have that same shape, but I'd like it to contract and expand depending on what the sleep time is. So what I'm going to do is I'm going to add a multiplier in here. So I'm just going to say, okay, can I want to multiply by the sleep time, but minus the sleep time times the gap. Okay, so that is hopefully going to allow me to, if I change the sleep time and the gap, so the envelope will contract. Make sure I've got my... Okay, let me just add in this also the global transposition. So the reason that I wanted to have two different transpositions there is because at the moment we're just picking up this number and we're using it as a MIDI number. But what if we wanted to use the number that's in the word and use it as frequency? Well, the way we would do that is to basically amend this so that we would, instead of just playing the pattern like this, we would convert it to hertz to MIDI, and then put everything that's in there inside that, and lo and behold, that will get converted. But what I know will happen is that the transposition will need to kind of have some sort of global transposition to make sure that this is in a range that it's going to be suitable for the piece. It's not going to go like crazily high or low. So and at the moment I know that when it's in MIDI it's really high, and actually when it's in hertz it's going to be quite low. So so basically what I'm going to do is I'm going to say, okay, if it's MIDI, then add in the global transposition for 0, and if it's hertz, put the global transposition for 1 in there. Now, how am I going to determine whether I'm going to be playing in Hertz or in MIDI. Well, at this stage, we could also think, how are we going to determine whether we're playing a sequence of notes or a chord? Because remember, we had this value here, which we call chord, which can be passed in. So let's just address that first, and then we can give it actually one of 4 options. We can play MIDI as a chord, MIDI as a sequence, Hertz as a chord, Hertz as a sequence. So let's see how we would do that. Right, I'm just going to duplicate the MIDI one. And put it in there. And basically, the thing that we're going to change is, instead of playing it as a ring, i.e. one note after another, we're going to take the whole of the pattern and just create a map of that pattern and play it all at once. So we don't need tick and we don't need ring, but what we do need is map in there, and then we can, it requires a little function in here. So we just basically take each of the notes, which I'm just going to call N. Could call that anything, to be honest, but I'll just call it N, and then I'll add all the N's together like that, and at the end of that I'll put in the closing function thing there, and that looks like it should work. And got the envelope, and then if I do the same thing for Hertz, actually it might be easier if I do there. In here I need to put to MIDI and then change that number that we get there, the Hertz, and that should, so we're taking that, basically all those MIDI numbers are coming in, and when they're coming in, changing them to Hertz before we add them up. Now I want to distinguish, depending on if CRD is 0, I want it to do that, 1 do that, 2 do that, 3 do that. So what I can do, SyncPy's got a nice way of having decision trees. So I can just say if CH, what have I got it, RD, do this. So it's only going to do that line if CHRD is 0. And it's going to do that line if it's 1. It's going to do that line if it's 2, and it's going to do that line if it's 3. So it's only ever going to play one of these. Hopefully CRD is only ever going to be 0, 1, 2, or 3, and because I'll make sure it is, and then it would choose which one to do, whether it's going to play a chord or whether it's going to play Hertz or whether it's going to play the MIDI note. So we're just adding in a little bit of variety into the instrument. You could think of it as, I don't know, tuning systems or something on the string instruments, but not really. So let's see if we can test this out then. Let's go up here to our patch now. So we can now say use patch 0, repeat it 4 times with a length of 4, sleep time of 1.25, a gap of, we'll keep it at 0 for now, and we'll test that in a second. We want the sounds 25, which will be the piano, I think. We'll keep with that for a second. Effects 1, we'll just leave the effects for a second. Transposition 12, and then, okay, CRD now. So we'll call it, we'll leave it at 0. So we should get the, sequence, linear sequence, and then we've got the envelope at 1, and we've got the amplitudes. We're not using the amplitude yet. Okay, that's fine. So let's see what happens when we run that. We'll probably get a few errors, typing errors. Okay, cool. So let's see if we get the chords this time. If we change that 1 to no. Change that to 1. Okay. Okay, sounding a little bit Stravinsky like those hard chords there. Okay, so let's see if I change that to 2. Okay. Okay, so these have been transposed now down into, audible or usable ranges, and that was the hertz, and the other one was the MIDI notes. Okay, so we've got something. Let's see if this one will work now. So if I move that to 3. Okay, sounds interesting. Right, we're getting some interesting. I wonder why that's sounding like that. Okay, well, anyway, that's what it's throwing up at the moment. So we'll leave that for now, and we can come back to that because we're going to have to fine tune these anyway when we start to put them into the score. So we've got the okay, so we've got the gap plugged in now. We need to test that actually. We've got the transposition plugged in. That seems to work. We've got the chord definitely works. The envelope, we need to test that as well. Amplitude, let's see what we can think about in terms of amplitude. A lot of some of these things, of course, we could have loads of control over, but for the sake of this, we're going to just hard code some certain things in. So basically, for the amp, I'm not going to put any processing behind that. I'm just going to take the amp, and whatever the amp is passed in, I'm just going to use it for the amplitude. The pan, okay, yeah, the pan, right, okay, what I'm going to do with the pan is I'm just going to let whatever goes in here, it's going to be a 1 or a 0, and it's either going to be not panned, or it's going to pick up some random panning that I'm going to just program in here. Okay, so we've got the amplitude and the pans now in all 4 of the players. So we can take those out. We take those out. The last thing is this idea of the some sort of cutoff thing. So there's, if we use a feature in Sonic Pi which is called a line, we can kind of plot the movement of a parameter from a lower point to a higher point with across with a certain number of increments quite easily. So I'm just going to set something up called CO, variable called CO, which we'll use for, in this instance, a cutoff, and I'll just say, okay, can we have a line which goes from this parameter here that's going to be submitted to that parameter in these increments. Now, what are the steps? I really want them to be the increment to be dependent on how wide the low and what the distance is between the low and a high. So I'm just going to say CO high minus CO L, and then divide that by the increment. Now, I don't want it to just go one way. I would like it to kind of go like somebody's moving the knob one way gradually, and then back the other way, and up and down like that. So I want that to happen. So I can use something called mirror, which will allow it to do that. And then I want my sort of incrementer, which is the tick, and I'm going to create a special tick just for the cutoff. So that's looks like it's okay there. And then I can literally in here I can say let's do a little bit of testing, see if any all of this is going to work. I'm going to put back my debug to false, so that we can get rid of some of that junk in there, and I can put my own messages in. Okay, to start off with, let's just see what happens, what errors I get when I hit play. Okay. Okay. So here, this is 0, so that's not doing any good. So I just need to put a check in there to I can just in case a 0 slips through here. 1 if. On, so let's see what we've got. So now we've got the on off, the pattern is 0, that's fine. 4 4 1 2 5, we've got the sleep time, we've got the gap, we'll leave that one. Sound, then we've got 3fx, then we've got -12 transposition, we've got the chord which is set to 2, I'm going to set that to 0. Then we've got the envelope which is 1. Yeah, we can say that the amplitude is 1 now, and we've got the, so we'll say from 40. It's not going to make much difference on the piano sound, I don't think. Increments 1, and the pan we'll leave at 0. So okay, so let's just change that to say something like, look on my list, so sawtooth wave will be number 9. Okay, so let me just change that to, so we've got 8 of those repeating. Let's see if we can get that. Why is that cutoff not working? It's 1. Oh, it is. Okay, it is working. Maybe I'll increment it by 2. See if we get it. Okay. So right, so we've got we have that first word being played by the sawtooth wave, and the cutoff is working there. Everything seems to be working. Sustain. Let's check the sustain and the gap. Right. So if I now move the gap from, so the sound is 9. I move the gap to something like 0.5. So actually that's in the wrong position, isn't it? It's that side. So the gap is 0.5, and hopefully that will calibrate itself now with that same envelope. Okay. And if I open it up a bit, or close down the gap, I mean, yep. Okay. So right, everything seems to be working now. Let's just check what we've got in terms of any of our parameters that are still loose at the end. No, we've covered all the parameters, and the player is playing. Okay, so the last thing I want to do just for the instrument is I want to just think about the length of the pattern a second, because I quite like the fact that each of these has a different length. That's going to be the pattern length because of the letters in the word, but I also am mindful of the fact that I might want to manipulate that. So I might want this one to be 5, so I might want there to be an extra M on the end if I'm trying to sync things up. that could be useful to do that. So what I'm going to say is I want the length, if it's just 0 in the patch for length for this one, so on off, if that one there is 0, then I want it to just pick up whatever the length is of the word. But if it's got a number in there, I want it to just pick up the number. So if I want it to be 4, then it will just truncate that to 4, or if I make that 5, it will add 1 onto 5. So before I do the length here, I'm just going to say length equals whatever the pattern length is. Okay, if len has been passed 0. And I also want to make the pattern length 1 if chords have been selected. Yeah, because I don't necessarily want to have complete control over that, and I'm just going to use the repetitions to control that. So I'm going to say if CHRD equals 1, which will be the one for the MIDI notes, or 3, which will be the one for the hertz, and then it can do its thing, how many times round that is. Okay, so all that remains to do now is firstly we need to create multiple players. So let's I'm going to go for a quartet of players, and these need to be in thread, so that they're all synced together. And then I need to make sure they have their own identity. 1, 2, 3, 4, and then so I can say that this one's called player 1, playing part 1, player 2, playing part 2, okay, so literally clones of each other, and so all we need to do now is to just test out some patches. We've got our 4 players here, and we need to four parts on the score. So if we just play, okay, we've still got that very tiny large gap there, so I'll make that 0, I'll make that 25. So the piano part, I just want to check something, that the chords are working, because we didn't check that. So it's transcription, then there's the chords there, right? So I'm just going to try that. So anyway, this should be piano. Okay, good. Chords. Good. Hertz. And hertz chords. Oh, that doesn't sound right to me. Okay, so okay, we're picking up the wrong global transposition there. We're picking it up for the MIDI notes, so that's what that is. So if I play that again, okay, great. So we've got some punchy stuff happening there, right? So the thing to do now would be to just test out these patches. So if I go through, in fact, I'll turn it back to the sequence in there. So if I open this up, we can see what word is being played here. If I take that to 1, okay, there's more constraints. Oh, that's nice. Okay, there's an exclamation mark in there or something, which is causing some weirdness, but that's fine. The Okay, so now with the combination of this and changing the parameter space for the patch, I can start to create some more patches down here, and then build them into a score. Okay, so I'm just going to get rid of these ones we put in so far, and I'm going to start from scratch. And the first one I'm probably going to put in is an 8-bar rest, and then make patches after that. Right, so the last part of the process is to add the score, and I'm going to start from scratch here. So this is where I'm putting in the 4, if you like, parts for each of the players to play, and they're just a sequence of the patches that they'll play, and of course the patches have their timing component inside them, so there's no need for a scheduling at all. They will just follow one after another depending on how long they're going to last. So I'll quickly do that now. So just before I play the piece, I'm just going to let you know a couple of things. You'll notice in the score that there are some 20s at the beginning here. That's just rests, the lead time. So you can see patch 20 here is 4-bar rest. And I've added some other rests, 19 and 18 as well. They're rests, 1-bar, 2-bar. And we've got an 8-bar rest, which is patch 0. So when you see those ones, 0 and 18, 19, 20, they're rests in there. You'll notice that the 8s don't have a leading 0, nor the 9s, because Sonic Pi thinks they're hexadecimal. If you put those in front. Oh, I just noticed that needs to go. So I can bring this up a little bit. And the last thing is, it would be good to have some little idea from the players what they're actually playing at any one time, so that it will help follow the score if you wanted to do that. So I'm just going to ask them to tell us something about what they're doing. So I'm asking it there to tell us what. So the first parameter in the string of the patch is what word they're using. So I'm asking it to tell us what word, but I'm only asking it to do that if parameter 13 is not equal to 0, because parameter 13 is the amplitude. So I know that if the amplitude's 0, because I put all the rests to amplitude 0, I know they're not actually playing anything, so we don't want it to tell us anything about that. And the other thing is just to give us which section they're on and which patch they're playing. So this will tell us display 0. So now I can copy and paste these into the other players, and hopefully if I change their player number, so this is player okay, good, that seems to be happy with that. So if we go up to the score now and I just run it for a second, we should get a report back from the player when it starts to play. Yeah, great. So player 0 has told us that they're playing the word more and they're in section 1, and lo and behold they're playing patch 2. So that if you watch this panel here, the post window, you should see some orientation about where you are in the score and which patches are being played. So okay, so we can play the piece now and see how it goes.